Hi, welcome everyone. This presentation is about human activity recognition using smartphone. My name is Israr Ahmed. I'm a PhD candidate in British University in Dubai. This presentation is about an assignment from Advanced Analytics. And here the main purpose is the first thing we need to select a data set that I selected as human activity recognition, and then we need to survey 10 research papers. They are using the same data set. So actually I reviewed 10 different research papers related to human activity recognition, means that they have used this data set in their research paper and they have done different experiments. So here's the outline of my presentation. First, I will introduce what is HAR, or human activity recognition. Then we will discuss the goals of this whole data set and what research has been done using this data set. So here's the literature review. Here is the heading of the papers that I've used, and I made a research on them, and I did find some interesting facts from these different papers. So the next here we will discuss about methods, the results, and then the conclusions from all this study, from all this work done. What is HAR, human activity recognition? Actually, it's a data set, and that's about they did experiments on people using smartphone sensors, like how the people walk, how the sensor respond when the people start walking, when they are laying down, when they are moving up in stairs, when they are coming down. So this data set has a lot feedback, and people reacted to it, and they use it in their research and did a lot of experiments and a lot of things on it. So they are using sensors to identify human activities. Activity recognition is people has a lot of interest in recent years due to its potential and usefulness. It's smart homes. Basically, the purpose of activity recognition is to gain the interest of people from low-level data acquired through sensors in given setting based on what their critical decisions are made. For example, in smart home environment for aged people, for senior people, senior citizens, we can have a monitoring system for them based on the information provided by the cameras, and then some other sensors we can use. The system need automatically monitor the problems, the issues, and we can determine what they need, like in terms of assistance. Even we can raise an alarm if required. So HAR is used in many ways, even in daily activities of the human beings, as well as it's used in the medical field, like for different type of people who are having diseases. They capture their emotions, their feeling in terms of different activities, and then it's used to help them to get rid of or to cure about their disease. So there are different sensors. Sensor types are here. So we are using inertial sensor, or even we can use camera, one camera or both side cameras of the smartphone, and the GPS system. Human activity recognition has been studied for years, and researchers propose different solutions to attack the problem. The recent approaches use vision sensor, inertial sensor, and mixture of both. We can use one or more cameras to capture and identify body posture. Approaches that combine both vision and inertial sensors, they have been proposed mostly. Another essential part of all these algorithms is data processing. The quality of input feature has great impact on performance. Some previous works focused on generating the most useful feature from the time series dataset. The common approach is to analyze signal in both time and frequency domain. Active learning technique has been applied on many machine learning problems that are time consuming and labor expensive to label samples. Some applications include speech recognition, information extraction, and handwritten character recognition. Smartphone is used for the purpose since it's easier, simple to carry, and even we can attach easily to the body. And then different activities were recorded from different people, and then different research were done accordingly. Two inertial sensors were used, accelerometer and gyroscope. A gyroscope is a device that uses Earth gravity to help determine orientation. Accelerometer is a compact device designed to measure non-gravitational acceleration. The main difference between the two devices is simple. One can sense rotation, whereas the other cannot. The typical two-axis accelerometer gives user a direction of gravity in an aircraft, smartphone, car, or any other device. Gyroscope is intended to determine an angular position based on the principle of rigidity of space. So it looks for the position, and the accelerometer just look for. So here is the screenshot of the dataset. It's from the UCI. Here it's used by many people, and it's a multivariate time series dataset. As you can see, number of instances 10,299, and it was number of websites, it's more than 65,000 hits. And then the tasks that are associated are clustering and classification of the activities of human. The goals here of this presentation is we want to compare and find a model that's best among them in terms of accuracy and efficiency. Why it's important that we are using a human activity recognition as a data set. So it's used for many purposes, even for health, as we discussed. It's used for even checking the performance of the mobile itself, how much it is good in terms of sensing the human activities. It can reduce the labeling time. Labor works using active learning. So these are the important goals here. The papers surveyed here are grouped as follows. We have unsupervised learning models. In this, the data is clustered, or it's divided in different classes and different groups. Supervised learning models, it's used to train the machine, and we want to get the desired output, the desired results from the machine. Inertial sensors application, so it's based on inertia or movement. These range from different inertial sensors. They can measure only a few square millimeter, up to ring laser gyroscope, which are extremely accurate but can measure 50 centimeter in diameter only. Here is the first paper in this literature review. This is unsupervised feature learning for human activity recognition using smartphone sensors. So to evaluate the problem of handcraft features, the author here represented a feature extraction framework which exploits different unsupervised feature learning techniques to learning useful feature representation from accelerometer, and gyroscope sensor data for human activity recognition. Here they used principal component analysis (PCA) along with sparse autoencoding based learning methods to adapt to the changes in the activity. To alleviate the issues of handcrafted feature, here they introduced a component extraction system which exploits diverse unsupervised component learning system to learn valuable feature representation from accelerometer and gyroscope sensor information. That's for the human detection moment. HAR include three stages: segmenting sensor data streams, extracting feature, and classification. For data segmentation, a widely adopted approach is sliding window technique, which is a fixed length window moving along the stream with some overlapping separates data flow to frames. As for any pattern recognition task, the keys to successful HAR are appropriate feature representation of the sensor data and suitable classification algorithm. They access the execution on an open human movement acknowledgement data set, and furthermore contrast the technique and conventional highlights to another method for unsupervised element learning. HAR has a great potential for application for human health and wellness. For example, we can promote a healthier lifestyle to who lacks adequate physical activity by monitoring and analysis the daily activities of him. They evaluate the performance on a public human activity recognition dataset and also compare method with traditional features and another way of unsupervised feature learning. So here the solution provided for these issues is utilizing the learning strategies from numerous information, which is data adaptive. They adopt channel-wise way which learns feature from each channel, then concatenates learned feature for all channel as the feature representation. So the outcome here represents that the learned highlights of the structure beat the other two strategies. The human activity can have several variations with respect to gyro value of device. PCA can generalize these variations to classify them into one category, for example, walk or run or sleep. The result shows that the learned feature of the framework outperformed to the other two methods here. The sparse autoencoder achieves better results than other two techniques within the framework. Here is another paper, Human Activity Recognition using Smartphone Sensors with two-stage continuous hidden Markov model. So the Markov model was used to explore human activity recognition using smartphone sensors. Here they proposed a method using RF variable importance measures for feature selection and two-stage CHMM, and that's continuous hidden Markov model, to diagnose human activities. RF variable measures continuous and possibly high correlated variables with two-stage CHMM are suitable for the characteristics of sensory data and the regular hierarchical structure of events. The public domain UCI HR dataset was used for all experiments, and it was collected from the Samsung Galaxy S2 smartphone that was won by 30 volunteers. They collected the dataset from there. Each volunteer was instructed to perform a protocol of activities 2 times, first with the handset attached on the left side of the belt and second with the handset placed according to the user preference as they want. This developed into a dataset with 561 features, all derived from sliding windows of 128 samples and normalized to values between 1 and -1. The dataset was haphazardly partitioned into train and dataset with 70% all allocated to the former data for 21 volunteers, the first 21 volunteers, and 30% for the latter for the 9 volunteers. All 561 features are fit to an RF to get the importance value of predicators. As observed on the significance measure output, variables with high importance scores for moving activities have noticeably low importance scores for stationary activities and vice versa. RF technique was adopted and processed the average of variable significance scores from every one of the runs. Factors with significance value more prominent than the mean significance estimation of all the factors are reserved and positioned in descending order. Then at that point they placed out a joint stepwise and tenfold cross-validation methodology on the preparation dataset and processed the mistake rate of the CHMM display beginning from the two generally important factors and ending with one including all factors kept previously. The factors of the model with the lowest mistake rate was chosen. The final product of this procedure was a component subset of 119 factors which were utilized as the component subset for the first level. The similar cross-approval method was performed to decide the ideal component subset for every subclass. It was proved that RF variable importance measure feature selection method is more suitable method to be used in combination with CHMM. The result are then shown that a two-stage continuous HMM classifier is a reasonable method toward universal activity identification on smartphones. Uninterrupted HMMs are able to specifically handle time series data such as accelerometer and gyroscope sensor values, and the two-stage architecture permitted to use a considerably smaller number of features at the same time utilizing the most effective ones. They also validated that random forest variable importance measure in combination with proper domain knowledge is an effective approach in uncovering the most valuable features from a large feature set. Here's the third research paper that was surveyed. Deep conventional neural networks for human activity recognition with smartphone sensors. A multi-layer neural network was explored to generalize human activity recognition actions. They used a variation of multi-layer networks called conventional neural networks. The work investigates different layers of the conventional neural network, and results show that by increasing the number of conventional layers, the neural network performance is improved as well. The performance in their work is measured by using prediction accuracy. Time series information has invaluable neighborhood reliance attributes. In addition, activities have a tendency to be progressive and interpretation invariant in nature. Thus, conventional neural networks misuse these attributes, which make it proper in meaning time arrangement sensor information. In the paper, they proposed design of conventional neural networks with sensor information accumulated from cell phone sensor to perceive activities. Analysis demonstrate that expanding the number of conventional layer builds performance. However, the intricacy of the determined highlights diminishes with each extra layer. In addition, having the data from layer to layer is more critical rather than blindly expanding the hyperparameters. The conventional structure can likewise profit by more extensive channel size and lower polling size setting. The network stores the high quality weights between the layer rather than adding randomness for restructuring in an evolutionary episode. The results are compared with different variation of support vector mechanism SVM. The results show that conventional neural network based learning approach perform better than SVM. The conventional neural network take benefit of using restructuring feature like dynamic setting for polling size and filter size. Here is the fourth research paper, that is transition aware human activity recognition using smartphones. So Reyes Ortiz present a tight time-bound classifier to categorize the human activities for HAR dataset. Their work uses the transition activities, for example, transition from running to walking as a category. Since there could be huge set transition activities, their work add ancillary category so-called unknown activities for new or exceptional transition activities. The main annotation behind mapping the transition activities is to refine the rules for identification of actual activity at a given time. Their work use a heuristic approach to filter the transition time frame, and they apply a probabilistic variation of support vector machines to predict the human activity. The algorithm is trained using HAR dataset. However, for validation and testing of the algorithm, their different datasets are they use different datasets for from three possible scenarios. One of the scenario include the test part of the HAR dataset. Other two includes live data from human participants using mobile and wearable devices. Using gyroscope of these devices, the data is fed to the model, and then model output is reported as correct or incorrect. The algorithm is compared with other variations of SVM, and results showed that heuristic based SVM variation perform better than its uh, rival techniques. So heuristic is a technique designed for solving a problem more quickly when classic methods are too slow. They use activity learning and activity and transition learning. So activity learning is the implementation only considered when basic activities in the learning algorithm PR SVM. Transition, on the other hand, are not learned. They introduce the idea of detecting unknown activities by assuming that transition lie between the clusters of activities in the future space. On the other hand, ATL is the implementation that include basic activities and transition together in the learning module. Transition are therefore considered as additional class. So the fifth paper is human activity recognition with smartphone sensor using deep learning neural networks. A variation of conventional neural networks is explored for HAR dataset. The authors explore different layers of neural networks to map the input features to the output classes given in HAR. The main feature of conventional neural network is their adaptivity with respect to the temporal variations in data. The restructuring of the network with respect to filter size and pooling size also add extra benefit to the algorithm generalization performance. The results show that lower polling size, for example 1 minus 2 minus 1 into 2 minus 1 into 3, can let the algorithm learn the mapping in a faster speed and with high accuracy. The results also showed that if algorithm is combined with Fourier transforms, where transforms are used to convert the inputs from one space to another, and conventional neural networks then generalized based. The sixth research paper is about human activity and motion disorder recognition towards smarter interactive cognitive environments. So HAR data was used to train the machine learning algorithm to detect motion disorders. The author here proposed the use of transition duration between two activities as indicator to detect the motion disorders. The work presents several feature selection techniques, for example, metric-based feature selection to detect motion disorder for classification of an observation, if it suffers from Parkinson's disease or not. The candidate solution for classification are k-nearest Neighbor KNN, Artificial Neural Networks ANN, Naive Bayes Classifier, and SVM. So this research assisted living and motion related human disorders. A special feature like ESANN 2013 was promoted, and they developed more interactive and cognitive environments. Innovative approaches was used to detect the human activities, and uh, they find very good results at the end. So here is another paper: human activity recognition on smartphone with awareness of basic activities and postural transition. So they use some basic activities. Here the author explored the use of machine learning algorithm to classify motion into different categories of transitory movements. For example, postural transition. Like many HAR projects, the mechanism to obtain user-related activity information was done through variable sensors. With these sensors, the attributes for describing motion, location, and psychological signals were easily and directly collected from individual. The author used HAR to set up a focused feature set for this purpose, which can act as an input for machine learning algorithm to generalize. The method used consists of parallel exploiting support vector machines SVM and temporal filters of activity probability judgment within a limited time window. The author presented a novel smartphone-based online HAR system for the division of activities, which takes into consideration the impact of PTs in the system accomplishment. Most of the HAR approaches ignore transitions between activities because their incidence is quite low and duration with respect to other activities was shorter. The benefits of the proposed approach is presented through experiment over a HR dataset, which has been revised with PTs and made publicly available. The author used support vector machine to train the classifier to detect transitory movements from the sensor value of the gyroscope of a smartphone. The result showed that SVM can detect these movements with high accuracy. Another research paper is about human activity recognition using variable sensors by deep convolutional neural networks. They try to achieve high recognition accuracy with low computational cost. Again, the signals from gyroscopes were used, and DCN, deep convolutional neural networks, were used as a feature. HAR dataset has been explored by the authors for application in wearable devices. Here they use a multi-layer neural network architecture to train the model to classify movement into normal or alignment. The movement data is transformed to a model image, and then Fourier transform is applied on the model construct image. The main motivation for such a transformation is to extract the potential valuable feature for heuristic based solution, which might be possible to identify by manual approaches. Such transformations generate a redefined pre-processing layer. The results showed that model perform better than without using transformations. The performance is measured using accuracy and computational usage. The optimal features of the activity image for the activity recognition task. They proposed three public data set, and it outperforms state of the with less cost. Another research paper is about activity recognition based on inertial sensor from ambient assistant living. So encompassing assistant living aims to make inventive specialized arrangements and administrations to help independent living among more senior adults, enhance their personal satisfaction, and lessen the expenses related with well-being and social care. The bidirectional display system immorally exploited motion data from smartphone, accelerometer, and gyroscope sensors to infer six basic activities, that is walking, ascending the stairs, descending the stairs, sitting, standing, and laying for both user groups in their ordinary environment. These six activity classes were commonly manipulated in human activity recognition experiments. In general, the safety of older adults living independently was serious requirement of AL application to avoid system failure. So algorithm organized in this domain should maintain high trustworthiness. In the paper, three learning machine algorithms are related: support vector machine SVM, hybrid of hidden Markov models HMM, and artificial neural networks ANN. And they were applied on a dataset gathered between aging and their caring ones. There were various methods to address the activity monitoring problem, verifying from video cameras, wearable sensors, and wireless sensor networks. They collected their own dataset in order to diminish the uncertainties and received 5,744 samples from 31 healthy volunteers varying from 22 to 79 years from 14 countries. To reduce the biases associated with their own collected dataset, they merged it with the public dataset for HAR using smartphone collected in a similar manner and at the same frequency. In total, 16,043 samples were accessible for training, cross-validation, and testing. Experimental results on real-life data show classification performance of over 90% for all three approaches, with SVM HMM achieving the highest detection accuracy. Here is the last paper for this survey: performance evaluation of smartphone inertial sensor measurement for range of motion. So smartphones are used as reliable and accurate for clinical motion research. Evaluation of different smartphone sensors performance was measured, and different algorithms were compared to the gold standard. They use it for industrial robotic arm. The dynamic and static protocol were used to perform these comparison. The root mean square RMS value results for static protocol are under 0.3 degree for the different smartphones. The root mean square value results for dynamic protocol are more prone to bias included by Euler angle representation. Statistical results prove that there is no filter effect on results for both protocols and no hardware effect. Smartphones performance can be compared to Zen's gold standard for clinical research. It was concluded from the results that built-in inertial sensors in smartphone are reliable for clinical fields related to standard tools like universal ganometer in static protocol. In dynamic measurement, they face the limit of Euler angles representation for McDavick and Mahoney filters. To avoid this drawback, it is recommended that algorithms can be improved, such as it can be monitored for manufacturer system filters. Regarding the methods, they used smartphone for data collection. The sensor that was used, accelerometer and gyrometer at the 50 hertz. They used cell phones in the pockets, and they use it around the waist, looking for different sensors response in different activities. So there were almost 30 peoples in most activities, and then there were 5 different activities like walking, biking, walking upstairs, walking downstairs, jogging, and limping. So in the future generations, there will be sampling window that can be proposed. That's 256 samples. There can be a mean 25 percentile with 75 percentile correlation average resultant acceleration. The frequency can depend on energy, center frequency, peak frequency, or entropy. And they can change the results based on the activities. The Classification techniques include k-nearest neighbors, support vector machine, and artificial neural networks. There were different queries and they were based on the uncertainty. And the main queries here was used was KNN, SVM, and ANN in different activities with different algorithms. So here are the conclusions for all the work done in this survey. Different works using HAR dataset are reviewed and analyzed. Mainly these works are in the category of supervised learning models, unsupervised learning models, and inertial sensor applications. Deep learning is the most popular solution for HAR dataset generalization. Head and Markov solution are suitable for live data generalization.